All right, welcome back, guys, to the third and final lesson in our series of Screencastify videos by Mr. Roberts. And so I'm going to be back in class tomorrow if you're watching this on Tuesday, or if you're watching this on Wednesday with me sitting right there, then hello. Okay. And so in this last video, we're going to talk about one final content before you guys have another assessment over this, probably. And this is called compound interest. So what we're going to do is, like I told you guys in person, got something on me. What I told you guys in person is that this chapter is one of my favorites because it's so real life. It has so much content that addresses real issues like spiders or money or things like that. And so it's not just basic, boring math problems, I hope. And this is going to be one of my favorite lessons because we're talking about money. So let's get started. Some vocabulary word. So you don't have to write any of this. You are going to have to write the formula on the next page, but I definitely want you to read over this. You can pause it if I go too fast and I go off of the screen faster than you needed. But this vocabulary word, compound interest. So when you think about interest, we're talking about money, and we're probably either going to take out a loan or we're investing money in something. And then compound means that it's compounded, or that it's computed, that it's computed very fast under a certain circumstances. So let's look right here at the definition. So this is when a bank pays you interest on the principal amount that you invest and the interest that you accumulate. So a lot of times when you invest money, they only pay you interest on the principal, on the original amount that you invested. And that's not the case for compound interest. They're actually giving you money for both the principal amount and the interest that you accumulate. So you're double earning money. We like this. I wrote this in all caps because this is one of the most awesome things to ever happen to people who invest money, because this makes our money grow much faster, because we're not just earning money on the principal, we're earning money on the interest as well. So the reason we have this in this chapter, and the reason I'm showing you this right now, is because this is an example of exponential growth in the real world. If you think you're going to do anything with investment banking or anything to do with the money sector at all, you're going to work for a bank, you're going to work for an S&P 500 company, this formula that I'm about to show you, you guys will see for the rest of your lives. Okay, and if not, oh well. So here's the formula. So pause the video, write this down in your notes, and I'm going to talk about the letters for just a few minutes. Okay. So the formula is capital A, which is not down here. So I wonder what the capital A could stand for. Well, that is the final amount. So this is going to be the money that you have earned after a certain amount of years. Okay. P stands for the principal amount. So what did you initially invest? 1 is a constant, and that's in here because that's 100%. So 100% of your money plus something. So you're going to keep all your money and you're going to grow it using a certain formula right here. R is the annual nominal interest rate. So the key word you need to know here is rate. And please remember that you cannot put in a percentage here. You have to put in the decimal. N is the number of times the interest is compounded per year. So we're going to talk on the next couple of slides about compounding monthly, compounding annually, compounding quarterly. So you need to know how many times a year is your interest being compounded. Okay, that not only shows up down here in this denominator, but it also shows up in the exponent. And then T represents the number of years that you're investing. So this is P parentheses 1 plus R over N. N, there's technically a multiplication symbol right there between the N and the T. So here's example number 1. You invest $2,000 at 4.5% interest that will be compounded annually for 18 years. Okay, so what we do is we go back to the formula right here and we plug in all the numbers that we know. So we initially invest $2,000. The 1 was already in the formula. 0.045. So what I did was I took this decimal and moved it 2 places to the left, divided that by 1, and the place I got this 1 from right here is that it says compounded annually. So N represents the number of times per year that something is being compound or that it's being computed. And so annually means one time per year. So we put that right there, and we put that right there in the exponent. And then 18 is the number of years. So if you have $2,000 to start, you're getting a decent but not great interest rate, and you do it for 18 years and you never touch it again. After the 18 years, you'll only have $4,416. That's not wonderful. You've doubled your money, but it took you almost 20 years to do it. So let's look at some better examples. Okay? What about this example? You only have $1,000 to start, but the interest rate is going to be much better. So 12% would be like a nice stock, a mutual fund, something a little more risky, but you're getting a really good payout. And so this is being compounded monthly. So we're not compounding once a month or once a year anymore. We're actually going to compound 12 times a year. So we put a 12 down here in the denominator, and we put a 12 right here in the exponent because it says compounded monthly. There's the key word right there. And then 30 is the years. And so what I want to talk about for just a second is not really the formula, because you should understand that by now. But we only put in $1,000. We had a good interest rate, and we left it sitting for 30 years, and we had $36,000. That's pretty good. I mean, you can't retire on that. That's about 1 year's of work for an adult. Okay. But we're definitely getting there. So what about this last example? All right. So you've saved up $50,000 and you've decided to invest it at an 8% interest rate that is compounded quarterly for 10 years. So you're late in life. You've got about 10 years before you want to retire. So you invest $50,000. Okay. And so what I did was convert this to 0.08. And then where did this 4 come from? Well, the 4 came from compounded quarterly, because quarterly means 4 times a year. Think about it. There's 4 quarters in a dollar. So anytime you see the word quarterly, please put 4. We put it up here times 10 years. And so what happened was we over doubled our money in only 10 years. So it didn't take us that long. We had a decent but not wonderful interest rate, and we still doubled our money. That's wonderful. Okay. So there's 3 examples of what happens. Now you guys have some bookwork, and if you're watching this at the end of Tuesday, then you can try to talk Miss Cash into not letting you do anything if you want. But if it's early in the class on Tuesday or this is Wednesday, you need to go ahead and get started on this bookwork, guys. Okay. All right. You have survived all of my videos, and I am done.